All right, here we go. Number 5. -8. Or p squared equals 36. Divide by 4. P squared equals 9. Square root. P equals plus or minus 3. Moral of the story in that problem, don't forget the plus or minus. Don't forget the plus or minus. Don't forget the plus or minus. Don't forget the plus or minus.
If you forget the plus or minus, it'll be marked down.
Oh, yeah. So on the little corner of your note card, if you have problems like this, just write like, don't forget the plus or minus, like in the little box, and then put like a smiley face so that you can encourage yourself on your test. Perfect. Okay, now let's solve this mystery. So the question is, we know 4x goes, actually, we know 4x goes in the root looking at this guy. But the question is, does the 3 go here or here? Here or here? Does anyone want to take a guess as to where it goes? You want to take a guess? Go ahead.
Right.
Here?
Yeah.
The 3 goes here? Anyone else think the 3 goes here? No, you're not. You're just too shy to say. There are other people who think the 3 goes there. Actually, okay. So what I wanted you to think was 2/3 is less than 1. 2/3 is less than 1, correct? So if we put the 3 here, then that means the value we get will be bigger than 1 because you'll cube it and take the square root. If you cube it and take the square root, then you're going to get something bigger than 4x. You want to get something smaller than 4x. The 3 needs to go in the front, square outside. Okay, so it's 50-50. So unless you're having a full intellectual argument with yourself, it's 50-50. Okay, so I made you a little note here on your on the denominator. The little denominator there is the type of root that you have in that problem. So in this one, you look at the 3, that makes it a cube root. Okay, so now when we do number 8, we're actually going to do 4 warm-ups today because I don't want to do any on Friday because it's CPT. I don't want to rush us. And these 2 are super fast. So we're going to flip to 9 and 11. Okay, now. So the directions, write each expression in radical form. You don't have to do anything. You're just writing it in radical form. Okay, now hold that thought. So for number 9, the directions now say simplify. We're going to write it in radical form and find the answer. So the first one was just to rewrite it. The second one is to actually do it. Okay, so now what you know, this is the type of root. So that's radical form. I did not solve it yet. I just did radical form only. Does that make sense from what we did a minute ago, though? Okay, so then you do the parentheses in here first. So what's the square root of 81r to the 4th? 9r squared to the 1 is 9r squared. What's wrong? If there was another square root in there, then you could. But There's nothing, it didn't ask you to do anything else. That's it.
You just figured that.
Yeah. If there's no other roots or anything. Is it messing with you because 9r squared is a perfect square? Yeah.
Yeah.
No, you gotta walk away. You gotta leave it. Okay, last one. We're going to sketch the graph of these. These are exponentials. I don't know how much in exponentials you do in math 2. Might be 0, might be some, don't know. We do them in the end of math 1 for sure, like a lot. But I'm just going to remind you how this works real quick. These are very easy because it's math 1. Well, I shouldn't say that because domain and range is math 1 and that's not easy. But anyway, okay. So what you do is you look at the number in front, and that's the start. So 0, 4. And then the multiplier is 1/2. So you multiply by 1/2 each time to go through the table. So 2, 1, 0.5. Does that make sense to you guys? Is it coming back to you? Anyone? Okay, now we graph those 0, 4, 1, 2, 2, 1, 3, 0.5. And then this is one that has an asymptote. It has an asymptote on the x-axis. If you can see, it's going to approach that, but never cross, because you're just going to keep cutting this number in half for the rest of your life, and it's never going to be 0. You guys see why we did 4 warm-ups today. They were very, very fast. I believe that you guys are done with your packet. Yes, you're done with your packet. Packet can go away. All right, now I'm expecting, maybe not, maybe so, a very big unhappy sigh when you realize what we're doing today. Today we're doing projectile motion problems. These are the ones where you have like Mrs. Talbot riding a horse and jumps over the fence and find an equation. Remember you had the packet of those, hits a golf ball and it goes up and lands and you have to figure out the equation.
I do not like that.
Yeah, that's okay. Now I have to say to those of you guys that did this online, I have no idea if they did any modeling problems. I don't know if you have any physics problems at all from that. This might be completely new, but it's easy. So, I mean, it's easy now. It really wasn't back then. But now after everything we've done, it should be, no, not easy. Okay, anyway. I do want you to have a graphing calculator because we're going to use it to cheat on the fraction part. Okay. We're going to do 3 problems. The first one, 13 and 14, the first set is not too bad. The first part of 15 isn't bad. You should know the second part of 15 is spicy. So just prepare. And then homework tonight is 18 through 21. And it says, if I had just had 1 hour left to live, I'd spend it in math class because it never ends, which is very fitting for the block day today. I used to have that t-shirt, except for it's take out the words math class and replace it with swim meet. Yeah, because swim meets are where you get up at 6 in the morning and you come home at 5 in the evening and you watch your child swim for 30 seconds total. And the rest of the time you're just drying them off and making sure that you have their towel and their giant parka and their UGG boots that you can carry to the end of the pool. That's what a swim meet is. If you've been to a swim meet, you know exactly how accurate that is. Like you're on the way to Stockton and your kid's like, oh, I just decided to do just the 50 free. What? we're driving to Stockton for you to do the 50 free. This is what you're telling me on the way. I don't have any experience in this though. I do. Yep, word problems today.
Wait, do you need to write a rabbit?
Yes, yes. You'll have no idea what's happening from your notes if you don't write that down. You guys that took this online, you'll have to tell me after the class if you did this before or not, or if it's completely new. I'm not worried about your ability to pick it up immediately. I'm just curious. Okay. So we're going to do two things in this problem in number 13. And I didn't write it all out for you. I just put the parts that you absolutely needed. The first thing we're going to do is sketch it. And the second thing we're going to do is write the equation. So the actual notes are to write the equation, and we want it to be in graphing form like we did yesterday. So what do we need for graphing form? We need to know the width, the A value, we need to know the vertex. Okay, first, sketch the situation. So let me actually show you the picture on CPM real quick. Here's the jackrabbit jumping. You can move the jackrabbit wherever you like. I like to start my graphs at the origin. I don't know why they put it back here, but that's fine. So just so you know, it's jumping in a parabola kind of setting. No, click the wrong button. Okay. So I like to start my equations off at 0, 0. I feel like that's easiest. Some teachers will have you like back it up to -4 and then have the height of it at the X or at the Y axis. That's fine too. There's actually an infinite number of correct answers for this problem, depending on where you start your jump. But I like to start mine at 0, 0. It says it begins its jump 4 feet from the fence. So I'm going to go 4 feet out. And I'm going to draw a little fence. And I'm going to very specifically make my fence 3 feet tall. Okay, then I'm going to say, okay, we studied parabolas the last 2 days. One of the things we said repeatedly was that they're symmetric. So the rabbit should come down the same distance away. And then the hard part about this is sketching it nicely. And you're like, Mrs. Talbot, isn't the rabbit going to hit the fence right there? Just, you got to let that go. Like this mathematical modeling. Okay, and then the last thing I'm going to do on my sketch is label the vertex. Anybody have any questions about my sketch? Does it seem reasonable? Okay. Step 2. plug in the vertex and a point. Okay, and I'm going to label these things very clearly over here. The vertex is at 4, 3. And I need to get another point on the parabola. There's 2 to choose from. Can you guys tell me what 2 other points I could choose from? 0, 0, yeah, or 8, 0. Perfect. So either one of those 2, you know for sure, 0, 0, or 8, 0. You get to choose, but I'm a lazy human being. I'm always going to choose 0, 0 if I can, just because I don't want to do math extra. Okay, now what do I plug it into? I plug it into the graphing form. And I'm going to get a different color out if you guys like to make your notes colorful. My vertex is always HK. And my other point is always XY because it's an XY coordinate. And then I plug those things in, and A will be what I solve for. So Y, what number is Y? 0 equals A. A is what I'm going to solve for. What's X? 0. H is 4 squared. K is 3. Any questions about what I did here? Where I put the stuff, you good? Okay, now some students mess up their order of operations right here. So what I always tell kids is just to save yourself from making the mistake is to save that 3, rescue the 3 out of there first, get the 3 to the other side so you don't accidentally combine it with those unlike terms. So save the 3, rescue it right away, get in there, get it out of there. Now I'm going to show all the steps. I'm sure that most of you know that this is 16 already, but I'm just, because it's notes, I'm going to show everything. There are going to be some of these problems that it is much better to leave it as a decimal. There's going to be some problems where it's better to leave it as a fraction. I'm going to show you how to go back and forth on your calculator in a minute. But just for now, this is not a bad enough fraction for me to care about rewriting it or anything. Okay, anybody confused about what I did so far? You good? Okay, so the last step here is to write the equation. Y equals -3/16 x minus 4 squared plus 3. Pause right there and make sure that you understand where all of that stuff came from. You know where the -3/16 came from? From there. Do you know where this 4 came from and why it's minus? And then where the 3 came from. You guys solid? Doesn't it seem easier now this year?
No.
Poor thing. All right. And for number 14, I need to show you the book. Write it out. It's going to be off of the same problem, but let's take a look at the book. The jackrabbit is jumping along and encounters a brick wall. That sounds kind of scary for the poor jackrabbit, but it's fine. That is 2.5 feet high and 1 foot wide. Can he clear the wall if his jump is the same height and width as problem 2-13? If so, how close to or far away from the wall should the jackrabbit be when he jumps? Use your model to decide. Okay, so we're going to use our equation from number 13, but we have to see if he's going to hit this wall. It's 2.5 feet high and 1 foot wide. So we have to make sure that we sketch that properly. So the hardest thing about this really is the picture. Okay. So we want it to be the same width. This is still going to be 0. This is still going to be the vertex, the height of the maximum of his jump. And this is still going to be where he lands. Okay, and we're going to draw this wall in. So it says it's 1 foot wide and 2.5 feet tall. So what I'm going to do is I'm going to go to 4 and I'm going to go halfway in either direction. So I get that 1 wide. And 2.5 feet tall. Okay, then I'm going to put the vertex up here where the top of his jump is from the previous problem. And I'm going to draw my parabola in an optimistic fashion, hoping that he doesn't smack himself on the corner of the fence. Okay. My goal is to figure out how high he is right here and right here. I want to find how high the rabbit is at this corner of the brick wall and at this corner of the brick wall. Would you guys agree with me that those are the most dangerous spots for the rabbit? Okay, so what is the x coordinate right here? X is what right there? 3.5. And what is x right here? And what could I use? Oh, hold on. Let me assist you. What could I use to determine his height at x is 3.5 and x is 4.5? Plug it in, right? Okay. So I'm going to do it twice. Do we kind of have to do it twice though? No, why don't we really have to do it twice? Yeah, we know the properties of symmetry. Okay. Y equals negative 3/16, 3.5 minus 4 squared plus 3. Okay, let's practice typing this in. Make yourself do it. It's good practice for you. First, you need to type the negative. That's at the very bottom under the 3. And then for a fraction, I just type 3 divided by 16. You don't have to do anything fancy for a fraction. Just do 3 divided by 16. Parenthesis is right above the 8. 3.5 minus 4 squared plus 3. Okay, here's my question. Did he clear the 2.5 foot high fence if he's 2.95 feet up? Yes. Oh, thank goodness. We don't have to talk about the poor jackrabbit hitting himself on the. And I really don't even have to do that math because I know that it's going to be the same height in both spots. Okay, now number 15A is where you guys are going to have a chance in your groups to do this. So you're not going to do this. There's not any of this. You're going to sketch, plug in the vertex and a point, get the equation. I am going to put this up first so you can draw it. I'll give you a scale hint. I went by 15s on the x-axis and 25s on the y-axis. You're going to have to go further. Okay, so just set this up real quick. Then I'm going to put the problem up from the CPM book, and then I want you guys to do this one. You just need to sketch, plug in the vertex and a point, find the equation. Don't do B, you're just doing A. Definitely talk to each other. First step, sketch it, find the vertex. Big table of 5 found the vertex. I heard them. You guys got the vertex. Nice one. Okay, this is your first little picture. The height should be 100 at 75 feet, so the vertex should be 75. And you can choose 2 points. You can choose 0, 0 or 150, 0. But I'm not going to choose 150, 0 because I'm way too lazy. Ignore the pink line. That's for B. You will not have a pink line yet. Yeah. That's actually why I had everyone get graphing calculators. I'm noticing a lot of you guys are getting the proper A value, but you're getting the wrong sign. This is an upside down parabola. Check your sign. Okay, here's the stuff plugged in. This is your next little reveal. That's what you should have after you plug it in. And then remember, my piece of advice, get rid of the 100, save it out of there before you make a dumb mistake. Okay, I showed some people the calculator. Let me help you out with the calculator. The whole reason that I had you get the graphing calculator out was for you to be able to make this into this. And some of you guys put decimal answers. Decimals work great if they end, but I don't know if you guys noticed the decimal for this is not pretty. So negative 100 divided by 5625 is gross. It's negative 0.017 repeating, which is not going to come out nice. I don't like it when they repeat like that. So what you do is, are you all watching? Reminding you, I think we did this in the first chapter just like one time. You hit the math button right here under the green one. Math, enter, enter. And then your calculator will change that gross, horrible, terrible repeating decimal into a beautiful reduced fraction. Math, enter, enter. We'll fix that for you. Kind of cheating, yeah. But we kind of figure like if you're advanced enough to be able to operate this calculator, then you shouldn't need to reduce fractions by hand. Okay, any questions about this process here getting to this? Anything you want to talk about here before we move on to the spicy part? Like that wasn't the spicy part? No. No. This should be, you know, moderately spicy. Like maybe a medium salsa. Okay, but now we're going to get to not like ghost pepper or anything, but spicier than that. Now, notice I didn't do it because I already did it earlier. So this is like a cooking show right now. You guys know what I mean by that? It's like, oh, let me put this pot roast in the oven. Let me get this other one out that I put in an hour ago. You know, that's basically what's happening here. You guys should have this. And this is, okay, so this is the final answer of A. All right, now we need to read B. Okay. How far horizontally is the ball from Miss Bibby when it is 25 feet high? You read that one more time. How far horizontally is the ball from Miss Bibby when it is 25 feet high? My first question, 25 feet high, is that an X or a Y? Y. Okay, beautiful. So you're gonna go, then you're gonna see how terrible this is in just about a second. Do you see how terrible it is now? Situation for B. Okay, Y is 25. Instead of easily plugging it into X and solving it on my calculator, I have to plug it in there and solve for X. Yes. Okay, hold that thought. Okay, this is an extremely spicy version of the warm-up that we did that said solve by square roots. So that very first warm-up we did, just to remind you that we did today, it's here somewhere on my, anyway. The first thing we did was get the squared by itself, then we square rooted both sides, if you remember. Okay, starting here, it's gonna be a minute, so, just buckle in. Okay, first thing I'm gonna do, okay, wait, let me ask you this. Looking at this equation, what was the very last thing that happened to it?
You got 25.
Okay, true, that's true. Okay, hold on, that's not what I meant though. What I meant was, in the order of operations here, just looking at what is showing, what's the very final thing that happened? Plus 100, right? Okay, so I need to undo that first. And like I said before, you want to save that 100 out of there, get that constant out before you do something silly with order of operations. Okay. Now what came last? Just this part here. Nope. The multiplying by the fraction in front, basically, the fraction in front. So, but I'm going to undo this in 2 steps. I'm going to multiply by 225 on both sides. I want to keep consistent with the trig problems that we did, multiplying by the denominator to clear it out. And so on your calculator, go 225 times negative 75. It's going to be big. It's okay. This moment is where I'm going to abandon ship of exact form and I'm going to go to a decimal because it's just too gross. Okay, now just looking at the right side, what's the last thing that happened here? The square. How do I undo the square? Square root. But what do we have to remember when we do a square root? Plus or minus. Okay, and that's what Theo was just saying. It's like, wouldn't there be 2 answers for this? Yup. $64.95. What I'm gonna round to. gonna split it into two equations. Yeah.
What is the I mean?
What? Sorry, it's a plus or minus. A capital I?
Yeah.
This is my special font. How could your handwriting not be perfect? I don't even know how. 64.95 plus 75, 139.95. The last thing we're going to do is we're going to check these two answers for reasonableness. So I want you to scroll up to your graph for number 15, the sketch that you made, and I want you to draw a horizontal line at 25 high. This is what we just calculated. So this is my pink line that I did earlier. Draw me a horizontal line at 25. And then do my answers look reasonable? Does this look like it could be 10.05? And does this look like it could be 139.95? Sure. I mean, my parabola is not perfect, clearly, because I'm me, but those are pretty reasonable answers. Does that make sense to you why there's two answers at 25 feet? Not just because there's a plus or minus, but for physics sake, because it's going up and coming down. All right, the homework is 18 to 21. You guys have like a half an hour to work on it, which is amazing. Yep, good timing, Preston.